Nowadays, people are trying to live a healthy life, and the best way to live a healthy lifestyle is through exercise. We are here to put to test one of the most conventional ways of exercising, which is cycling. Now, we are to find the different concepts behind this rising phenomenon. First, have you ever thought of how much power or effort do you exert in climbing an uphill slope? Let's put it to the test. Okay? Our subject here is Flo, who is 92 kilograms and has a bike of 13 kilograms. He is to climb an uphill slope that has a rise of 2.5 meters and a run of 11 meters, thus having an angle of 13 degrees. If he wants to climb the slope at a constant velocity of 5 meters per second, the power required can be solved by getting the product of the combined weight of Flo and the bike and the constant velocity of the bike. Thus, he must exert a power equivalent to 1.2 kilowatts to climb up the slope. Let us now find out the power dissipated through the brakes if Flo needs to go downhill at a constant speed of 6 meters per second. This can be similarly solved by again getting the product of the weight and the velocity. Thus, the power dissipated through each of the brakes is 695 watts, which is the total power divided by 2. Let's now try another concept. We have here Renz as our subject, and let us find out the relationship of the linear and angular velocity. In physics, the angular velocity is directly proportional to its linear velocity, and we can also apply this to bicycles. Knowing the linear velocity of the bicycles, we can find the angular velocity of the wheels and vice versa. Knowing that the radius of the bicycle's wheels is 13 inches and Renz is cruising at the speed of 6 meters per second, we can find the angular velocity of the wheels by dividing the linear velocity to the radius of the wheel. Thus, the angular velocity of the wheels is 174 revolutions per minute. Through these concepts, we found out that if a body is moving at very high velocity and has a very large amount of mass, we can produce a very large amount of power. Hopefully, in time, we could produce electricity through these concepts. Once again, this is Ben Macomb signing off.